Hello everyone. Today I will try to do moment distribution method. Today we will try to do some examples on moment distribution method in structural analysis 2. So let us consider one example. This is a given example. Analyze continuous beam shown in figure by moment distribution method. Draw SFD at BMD. So this is a given example. So we need to draw SFD BMD and we need to analyze the given example by using moment distribution method. Okay. With the, that is our aim is to analyze this by using moment distribution method. Now let us consider this. This example. So our first aim is to, please remember, before going for the solutions, our first aim is to find out what is the fixed and moment of the given problems. So here, there are some standard cases for beams or fixed beams. The given fixed, what is the fixed end moment for those beams are given here. Okay, so here is given what are all the fixed end moment for the various some standard beams. Okay, here one in beam with the fixed beam with point load, what will be the fixed end moments? Okay, is given like with the beam with fixed beam with point load exactly at the center. Then what will be the FEM's fixed end moment will be WL by 8 minus WL by 8, and this will be plus WL by 8. MF of BA will be plus WL by 8. Similarly, if unsymmetrical loading is there, what will be the fixed end moment? If unsymmetrical loading is there, fixed end moment will be WA B square by L square. Similarly, this will be WA square B by L squares. So similarly, this is for if the fixed beam with 2-point loads. Sorry, 2-point loads. This is for proper cantilevers. So similarly, there are different some standard beam cases are given. What will be the fixed end moment for the same? Okay, what will be the fixed end moment for the same? So here and here. So it's given here. What will be the fixed end moment? So here it is given here. Sorry. So here, beam with UDL fixed end will be WL square by 12 minus WL square by 12, and this will be plus WL square by 12. Okay, so these are all the standards cases of fixed beams are given here. So beam with UDL, beam with UVL, all those things is given here. Okay, now. So now this is fixed beams with UDL. So it is plus WL square by L, WL square by 12, and this minus WL square by 12 is given. Okay, and like this. Now by using these some standard cases, find out what will be the fixed end moment for the same. Okay, now let us find out one by one fixed end. Our first step is to in moment distribution method, our first step is to calculate what is the fixed end moment or fixed end moments. Okay, let us calculate fixed end moments. Okay, fixed end moment, first step. So now let us take one by one. MF of AB equals to, it's a unsymmetrical point load. So what will be that? W minus WA B square by L square. Okay, this is MF of AB. Similarly, calculate what will be the MF of BA equals to plus WA square B by L square. Here what will be the W? W is minus 40, and A is what? 3 meters. And B is 2 meters. Okay, 2 meters, 2 square by L square. L square is 5 square. So write down the value. Similarly here, plus W is 40, L is A is 3, A is 3 square, sorry, 3 square into B is 2 divided by L square means 5 square. So L square means 5 square. So write down the value. Similarly, we need to write down the value. Similarly, let us write down for BC span. MF of BC that equals to MF of BC equals to what? Is subjected to UDL. Subjected to a UDL. So it is minus W L square by minus WL square by 12. So minus 10 L is 4 square divided by 12. Write down the value. Similarly, you can write MF of CB. MF of CB will be plus WL square by 12. So it is plus W is 10, L is 4 square divided by 12. Okay. Similarly, you can write MF of CB. What is MF of CB? This is also minus W L square by 12. So what is minus? Minus W is 10, L is 5 square divided by 12. So you can write down the value. Similarly, MF of CB will be plus WL square by 12. So plus WL square by 12. So this will be W is plus W is 10, L is 5 square divided by 12. So let us write down the what is the value of that one. Okay. Now we can write what will be the value of that one. So now we need to write down what will be the value of those things. Now please we need to calculate and we need to write down what will be the value of. So MF of BA, how much will get? MF of BA you will get, so this is what, minus 43 into 2 square by 5 squares. So minus 42 square by 5 squares. So this is given. So we will get, so here minus 40 into 3 into 2 square divided by 5 square. So you will get this one. You will get this one. So we will write in another this thing, another color, fine, another point color with another color. You can select another colors and you can write out. This you will get how much? Minus, I will get this is minus 19.2 kilonewton meter you will get, and MF of B will be 20. Sorry, you'll get plus 28.8 kilonewton meter, and MF of BC will get minus 13.33 kilonewton meters. Similarly, MF of CB you will get plus 13.33 kilonewton meters. So here MF of CB, sorry, this is BA and this is, guys, please, this is CD, sorry, CD, and this is DC, CD and this is DC. MF of CD is minus WL square by 12. So this we will get minus 20.83. Similarly, MF of DC will be plus 20.83 kilonewton meters. So this is the value we will get. Okay, this is the value you will get. This is the value you will get. Okay. Now your next step is to, this is first step is find out the fixed end moment. Find out the fixed end moment. Now our next step is to, now so here our next step is to calculate distribution factor. Use the notations DF. We need to calculate what will be the distribution factors. So we need to calculate what will be the distribution factors. We need to calculate what will be the distribution factors for the given example. Okay, given beams. Okay, let us consider. Let us see the beams. What are all the intermediate? So what are all the? So let us take this for reference. That beam. Let us take this reference for the beam to easy way of calculations. I will copy it here. So yeah, let us consider this like I kept here like beams. Now let us calculate. We need to identify the which one is the intermediate support. Let us say B and C are the intermediate supports. B and C are the intermediate supports, and A and D are the end supports. Okay. Now let us identify which one is the intermediate support. Let us identify intermediate supports. Let us identify intermediate support. Which one is the intermediate support here? B is the intermediate support and C is the intermediate support. Then what are all the respective members for the joints, intermediate joints? So the members, here I written the members. What are all the members? Here I have members like BA, BA and BC are the members. B and BC are the members. Similarly, what are all the for intermediate support C? What are all the members? Correct members? It is CB and it is CD. Okay, these are all the members. Okay, this is how it's a very easy of write down the distribution factors and something like that. Okay, now let us now what is the stiffness, relative stiffness for BA now? The relative stiffness for BA, now we need to remember one point. So while doing this, if with respect to intermediate support, if the far end is fixed or continuous, the relative stiffness will be I by L. Please remember the relative stiffness will be I by L. So please, very important, the relative stiffness will be how much? It's I by L. It's I by L. The relative stiffness will be taken as I by L. So if another way, if with respect to the intermediate support, if the far end support is simply supported roller or hinge, then your relative stiffness will be 3/4 of I by L. So these things we need to remember, 3/4 of I by L. So 3/4 of I by L. So okay, this is how we need to calculate. Here I is how much? Here I kept I. What will be the L? L is, you can see here, 3 meter and 2 meters, so it is 5 meters. So what is I by L? I by L will be, what will be the I by L? I by L will be 1 divided by 5. So 1 divided by 5, it is 0.2. It is 1 divided by 5. It is 0.2 I. It is 0.2 I. Similarly, BC. Now you can see here. You can check out this. You can check out that with respect to intermediate support B. 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 B will be with respect to intermediate support B, for BC member relative stiffness will be, so we can see with respect to C will be the continuous support. C is the continuous support. So if C is continuous support, then relative stiffness will be I by L. So very important. We need to remember, guys, please. If far end is, if you want, I will write down. If far end is fixed with respect to intermediate support, if far end is fixed, or if far end is fixed or continuous, if far end is fixed or continuous, far end fixed or or fixed or continuous, fixed or continuous, then K will be taken as K will be what? I by L. K by L. So very important. K will be I by L. Similarly, if for and is simply supported or roller or hinge, then K equals to 3/4 of relative stiffness will be 3/4 of I by L. Okay guys, the relative stiffness will be 3/4 of I by L. Okay, K will be 3/4 of I by L. So we need to remember this. So what will be the relative stiffness for the various conditions, support boundary conditions or support conditions? Okay. Now, so based on this, we calculated this. Based on this, we did. Then now with respect to B, C is continuous. This is I by L. I by L means 1 by I by 4. I by 4. So it is 0.25 I. 0.25 I. Then come to giant C now. With respect to C, B is continuous. So what is B is continuous if I by L be I by L. So then relative stiffness will be I by L. So this is also I by L. I by L is this is I divided by 4. It is 0.25 I. Then with respect to CD, D is simply supported. Then this will relative stiffness will be 3/4 of I by L. So 3/4 of what is I by L? I by L is 5. L is 5. So L is 5. So this is how much? L is 5. So 3/4 of I by L. 3/4 of I by L. So this will be 0.15 I. This will be 0.15 I. Okay guys, so this is how we need to do it. Now let us say next step is, next column is given as summation of K. Summation of K means we need to add at the intermediate joint summation of all intermediate supports. So, summation of all intermediate supports will be 0.2 I, 0.2 I plus 0.25 I. This will be at the point B. This will be 0.45 I. 0.45 I. Then this will be, what is that? 0.25 I plus 0.15 I. Then this will be 0.4 I. 0.4 I. Okay, 0.4 I. Then now we calculate what will be the distribution factors. So now the summation of K by summation of K. For this giant B, what will be the distribution factors? K by summation of K. So K by summation of K. So K by summation of K. So this will be what? 0.2 I. Sorry. So we'll write once again this. Sorry. This will be 0.2 I divided by 0.45 I. Then you will get this will be 0.44. Okay, 0.44. Then next will be 0.25 I divided by 0.45 I. This will be 0.56. 0.56. Similarly, here this will be how much? This will be, so this will be 0.25 I divided by 0.4 I we will get 0.625. Okay, 0.625 we will get, and similarly we will get this is what 0.15 I divided by 0.4 I will get 0.375 I. So these are the relative stiffness for the respective members. Okay, now please remember, guys, please remember this. So we need to remember that we need to remember the intermediate joint, the summation of the summation of distribution factors should be 1. So means BA is 0.44 and BC is 0.56. So if you add those two, you have to get 1. So this is cross check. You can check. This is not I. This is 0.375. So we need to cross check these guys, please. Let us make sure that the distribution summation of distribution factor at each joint is 1. Each joint is 1. So we need to take care of this. Okay, we need to take care of this. Now next step is moment distribution table. So this is called moment distribution table. Third step is what? Moment distribution table. Moment distribution table. Now first step is to we need to write it on the what is the joints. What are the joints? Okay. Then let us write down the members. What are all the members? Okay, members. Let us note it down. What are all the members? Okay. So what are all the members? So here it is member and distribution factor and FEM. 1, 2, 3, 4. 1, 2, 3, 4. So here you can add. Here you can add another column here. Here you can add another columns. Insert row below. Yeah, I added another this thing. So yeah, or we can take this on the first side. So yeah. And here I can write. So moment distribution table. Okay. So moment distribution table. Select row below. Now it is okay. Moment distribution table. Okay, this is moment distribution table. So now let us. This is the joints. Now what you have to do? Now let us consider. Let us consider the members. Now let us consider the members. What are all the members here? This is AB. This is BA, BC here, and CB here, CD, and this will be the DC. Okay. Next, write distribution factors for the respective distribution factors. Here BA you got distribution factor is how much? 0.44. And here what is the distribution factor? It is 0.56. And what is the distribution factor? It will be 0.625, 0.625, 0.625, and this is 0.375, 0.375. Okay, these are distribution factors. Then FEMs. Let us write down the FEMs. What are the FEMs? So what are the FEMs here? FEM is minus 19.2. What you got there? 19.2, 28.8, and minus 13.33. This is plus 13.33, and this will be minus 20.83, minus 20.83, and plus 20.83. Okay, these are FEMs. Now what you have to do? Now you can see the real beam here. Real beam you can see. So you know that the last support D is, what is that? Last support D is, it is a simply supported. Then what will be there if the last support is simply supported? Then movement at this point MDC will be 0. So MDC will be 0, means I need to balance that movement. I need to balance that movement, or I need to release that movement. I have some FEM movements here. So to make it 0, I need to release that movement. Release that movement means I need to make it 0. How I have to make it 0 this? So I need to release this, means so make it minus. If I make this is release, I can say, you can release the word release and carry over. I have to do it. Then you release the movement. How much I have to release? Release minus 28 at the DC. Release minus 20 point, sorry, minus 20.83. I am releasing and carry over the half of the movement to the adjacent support. Very important, please. Carry over half of the movement to the adjacent support. So we need to release any simply supported hinge or roller is there. I need to make movement at the summation of movement at that point. Means I need make it 0 at the moment. I need to make it 0. Bending moment at that point will be 0 because it is hinge. Then what I have to do? Release the movement. What is the fixed end movement is there? Minus 20.83. So that movement I need to release. Release means it is plus 20.83, means I need to make it minus 20.83 and carry half of the movement to the adjacent support. So how much it is? Minus 20.83 means it will be minus 10.41 will be carried to the next one. Minus 10.41 will be carried to the next one. Okay, that is next one. This is the case. Okay, now this is the case. Now next what I have to do? Next, let us say what are the, now let us write down the initial movement. Let us write down the initial movements. What is the initial movements now? Let us write down initial movements. So let us write down the initial movements. Now let us write down the initial movements. Then what is the initial movement now? Minus 19.2. So once again, better we add another row here. So to avoid the confusions, we'll add another row here to avoid the confusions. Yeah, so we'll add another row to avoid confusions. We'll add another row here. Okay. Yeah, initial movement will be minus 19.2. Minus 19.2. Initial movement will be minus 19.2, and here minus 19.2, and this will be 28.8. 28.8, and this will be minus 13.33 and plus 13.33, and this will be now minus 20.83 minus 10.41. This is minus 31.24. Minus 31.24, and now I made it 0 because that is simply supported. I made it 0 because that is simply supported. Now your next step is to calculate. Next step is we need to do the balance. Let us do the balance. Now I need to do the balance at the intermediate support. So which is the intermediate support? B and C are the intermediate support. So I need to do the balance. Movement at the balance, I need to do it. This is trial and error method. So what I have to do here, balance means, so add the movement at the giant B. Intermediate means B and BC should be added. B and BC should be added. Add bending moment at that point. B and BC. So let's see this thing. If you see, yeah. So BABC should be added. Then what I have to do? Add summation of, take summation of movement at the intermediate support, multiply with the respective distribution factors, change the sign, write down the values. Okay, now let us add this one. What is that? 28.8. So let us add those two values. What is that? 28.8 minus, I need to do it, minus 13.33. So how much you will get? You will get 15.47. 15.47. That should be multiplied with the what? Distribution factor, respective distribution factors. 15.47 into 0.44. 50.48 into 0.44. Change the sign, write down the values. Means 15.47 into 0.44, you will get 6.8. You will get 6.8. Change the sign, write down the values. This is the main important steps we need to follow, guys, please. Okay, main important steps you need to follow. Add summation of these two at the intermediate support. Do the summation of these two movements. Multiply with the distribution factor, change the sign, write down the value. Similarly, here you need to do it. So it is here how much you will get, minus, that is 15.47 into 0.56. You will get minus 0.866. Okay. Similarly, here we need to do it. What is that here? Here what I need to do? So plus 13.33 minus 31.24. So here what I need to do, plus 13.33 minus 31.24, we need to do it. It's a minus 17.91. Minus 17.91, multiply with the 0.625, change the sign, write down the values. Means what is that? Minus 17.91 multiply with the 0.625. How much will get? 11.19. Change the sign. Minus 11.19 you will get. Change the sign, write down the values. What is that? It will be 11.19. Similarly, what is that? Minus 17.91. Summation of these two movements. Minus 17.91. Multiply with the distribution factors. 0.375. Change the sign, write down the values. So I change the sign and I write down the values. How much it is? 6.72. 6.72. So very important steps, guys, please. Next step is we need to do the carry over. We need to do the carry over to the adjacent supports. So please remember where I need to do the carry over. Please remember, If far end is fixed, if the far end is fixed or continuous, I need to do the carry over. Please remember this means I need to carry the 50% movement to the adjacent support with the same sign. Adjacent support with the same sign means. So let us say with respect to B now, we can check here. With respect to B, A is fixed. A is fixed. With respect to B, A is fixed means I can carry over the half of the movement. Half of the means 0.5 times the movement to the support A. Similarly, with respect to C, what is that? With respect to C, B is with respect to B, C is continuous. Then I have to carry over half of the 0.5% of movements, 0.5% movement to the adjacent supports. Similarly, C to B, 0.5 I need to do, but C to D I cannot do it because it is simply supported or hinge. Movement that point will be 0. So this point we need to remember, guys. Please, this point should be noted. Okay, we need to remember this point. So you need to remember these points. Now let us do this one. What is that? Balance. I need to do the balance. Next step is carry over. I need to carry the half of the movement to the adjacent support. So minus 6.8. Then half will be what? With the you need to carry with the same side. Minus 3.4. Here I can do the carry over. Here to here. C to B to C I can do it. C to B I can do it. Why? Because with respect to C, B is continuous. With respect to B, C is continuous. So I can do that. So you will get minus 5.59, minus 5.59, and this you will get minus 4.33. Here to here I cannot do because it is simply support. Zero movement should be carried on that side. Okay. Now next, do the balance. Once again I need to do the balance. Okay, once again I need to do the balance. So balance. So here once again I need to do the balance. What is the summation of movement at joint B, intermediate support? It is minus 5.59. Minus 5.59. So this is summation of the movement at that point. So then what I have to do? As I said earlier, summation of the movement multiply with the distribution factors, change the sign, write down the values. Minus 5.59 multiply with the 0.44, minus 5.59 multiply with the 0.44, change the sign, write down the values. Means we will get minus. So we'll get so guys, please, this is plus not minus. Once again, why it is minus? It is plus. So 5.59 multiply with the 0.44, you will get 2.56. Change the sign, write down the values. Means minus 2.56. Similarly, this one minus 3.14. So minus 4.33 multiply with the distribution factor, change the sign, write down the values. So this is 2.78. Minus 4.33 multiply with the distribution factor, change the sign, write down the values. 1.62. This is 1.62. Now, what you have to do? Next step, carry over. Next step, I need to do the carry over. Means I need to carry half of the movement to the adjacent supports. I need to carry the half of movement to the adjacent supports. So here also, I can carry from B to C, C to B, carry over I can do it. Here to here I cannot carry. This is 0. Okay. Then minus 2.56, half of how much percent? 0.5 times the minus 2.56 I need to carry. So it is minus 1.28. Minus 1.28. and this will be 1.39 will get, and this will get minus 1.57 you will get. Okay, this is carryover. Next we can do another trials. Let us do another trials. So this is balance. Now once again I need to do the balance. Once again I need to do the balance. Balance means here we got 1.39. 1.39 is there. So summation of the movement of the intermediate support. Then multiply with the distribution factor. Multiply with the distribution factor. Change the sign. Write down the values. You do it. 1.39 into 0.44. You will get, how much you will get? Minus 0.616. Similarly, here we'll get minus 0.765 will get. Here minus 1.57, minus 1.57. Here it is what? Minus 1.57 it is there. Minus 1.57 is there. Now what I have to do? Multiply with the distribution factor. Change the sign. Write down the values. Means it is plus 0.98 you will get. 0.98. And similarly here you will get plus 0.59 you will get. Okay. Now what I have to do? Next I need to do the carryover. Carryover. Next I need to do the carryover. Means half of the movement to the joint A because that is fixed. Half of the movement to the from B to C because that is continuous. C to B because that is B is continuous with respect to C. Then here no movement should be carried. Then you will get here. Then you will get here minus 0.31, minus 0.31, 0.49, minus 0.383, minus 0.383 will get. Then movement of this will be 0. Then do once again do the balance. Then once again do the balance. Now if you do once again do the balance, it will be what? 0.49 multiply with the 0.44, change the sign, write down the values. It will be minus 0.23 and this will be minus 0.27 and this will be plus 0.24 and this will be plus 0.144. Now I need to do the carryover. So change the sign. Now we have to maintain the same sign. Sorry, not change the sign. That's only doing the balance, and this will be so here. So 0.23 divided by into so this is 0.115 minus 0.115 minus 0.115. This is 0.115. So minus 0.115. Okay, and this is 0.14. 0.12 is there. 0.24 12, and this will be 0.27 into 5. You will get 0.135. You will get 0.135. So this is plus. We'll get here. How much will get here? Plus you get plus 0.135. Here to here 0 is this. Here to here 0. Okay. Here to here is 0. So now we can balance this. Once again, you can balance this. Balance. So balance. So if you do the balance, it will be if you do the balance, it will be point, how much it is? Point, we'll cross check with this 0.49 multiply with the 0.44 points to 1 0.49 multiply with the 0.44 is 0.21. Then this will be so 0.45 multiply with 0.56, 0.27. Okay. So this case we will get max approximately we will get, guys, please. Now we can do the balance. Now let us do the balance this one. So if you do the balance, it will be 0.12, 0.12, 0.12, 0.12, 0.44. So we'll get 0.0. We'll get point. Here point. Change the sign, write on the values. 0.0528. 0.0528 you will get. So similarly at these portions, you will get how much you will get? 0.56 is point minus 0.0672 will get. Similarly 0.135, it is 0.135 is there. So here 0.135 into multiply with the 0.625, 0.084, 0.084. So similarly 0.050. Okay. So now I can end here. So we can you can end your iterations at these positions. We can even end your iterations at these positions. You can end your iterations, and you can end your iterations. You can stop your iteration at these positions, and approximately you can write down the final movements how much you will get. Final movements. Okay. Final movements. Approximately will get. You can cross check with the values. Approximately will get. This is minus. Roughly I'm writing, guys, please, minus 24 or 24.34. This is 18.54. This is minus 18.61 approximately I'm writing, and this is 22.15 minus 22.15, and this is 0. So nearby value will get. You can add all these values. So definitely will get nearby the values. Okay, nearby values. These are final movements. Final movements will get. Okay, and these are the final movements you will get at this instant. Next, what I have to do? Next, let us take the real beam. Let us take the real beam here. Let us take the real beam. Yeah, let us take the real beam. So this is a real beam. So let us take real beam, and so this is a real beam, and this is a real beam here. So it is a real beam. Okay. Then so let us take the real beam. Now what I have to do? Next step is to. Now you already calculated the some moments. So you got here MAB is what? Plus how much? 24.34. 24.34 kilonewton meter you got 24.34, and this is also MBA is plus 18.34 plus 18.34 plus 18.34. This is minus 18.34, so it's a 18.34 kilonewton meters. Okay, so it is pulling up. Similarly, this is plus. Okay. So this is plus, this is minus you got, and this is plus you got, and this is minus you got. Okay, how much it is? This you got 22.15 kilonewton meters, and this is 0 you got. So let us say you need to find out now support reactions. Let us say this is RA, and this is RB, and this is RC, and this is RD now. Okay, RD now. Now what you have to do? Now you can separate this. You can separate and write down those beams, and you can find out what is the support moment. So now we can divide this separately. I can write down the beams. So like this, and this is AB portions, and similarly I can write down this is for BC, and similarly I can write down CD. Okay, this is AB1, this is BC, and this is CD. Here I have, here what I have the loads we have. See, here I have loads like 40 kilonewtons, 3 meter and 2 meters. I have UDL here of 10 kilonewton per meters. Similarly, UDL of 10 kilonewton per meters. This is 5 meter and this is 4 meter. Okay, this is RA, this is RB dash, this RB double dash, RC dash, this RC double dash, and this is RD. Now by taking, now let us take let us take one portions one by one at a time and try to find out what are the reactions. Now let us take sigma MB that equals to 0, and here I forgot to write what are the moments we got here. So what are the moments we got, and also you need to show here. So here what are the moments we got here? It is, I got 0 here. I got here 22.15. I got here 18. Here I got 18.34. I got here, and here 18.34. I got 18.34, and here I got, how much you got here? Here I have 22.15 kilonewton meters. Okay, this is kilonewton meter, this is also kilonewton meter, and this is kilonewton meters. So here 24.34 kilonewton meters, and this is 18.34 kilonewton meters. Okay, now so I shown that. Now what is your next step? My next step is to, now let us consider next step. What is the next step? Let us take algebraic sum of, let us say equilibrium condition. Let us consider equilibrium sigma MB that equals to 0. Then what is the sigma M equals to 0? 24.34 into 5. Rotating clockwise it is plus. Rotating clockwise it is plus. So rotating clockwise it is plus. Then minus 24. Sorry guys, this sorry. Sorry. So it's not only for. Sorry here. Here RA into 5. This RA into 5. Rotating clockwise plus minus 24.34 minus of 40 into 2 plus of 18.34. That equals to 0. Okay, plus of 18.34, that equals to 0. Then RA equals to 17.15 kilonewton you will get. RA equals to 17.15 kilonewton you will get. Then this is the case. Okay. Now use sigma Fi that equals to 0. Sigma Fi that equals to 0. RA acting upward. RB dash acting upward. Minus 40 that equals to 0. Then substitute what is RA here. Let us find out RB dash. RB dash equals to 22.85 kilonewtons. 22.85 kilonewtons. Okay, guys. This is RB dash. Similarly, sigma. Now let us take this beam. Sigma MB that equals to 0. RC dash into 4. It is minus and plus 10 into 4 into 2. Load into distance into load into distance into distance by 2. Then minus 18.34 plus 22.15. This is MB. 22.15 that equals to 0. Then RC dash you will get 20.9 kilonewtons. This is 20.9 kilonewtons. Similarly, if you take sigma Fi that equals to 0, RB double dash acting upward plus RC dash minus of 10 into 4 that equals to 0. Then find out what is RB double dash. RB double dash you will get 19.1. Okay guys, 19.1 kilonewtons. So similarly, now here you can take RHS side and you can calculate. Okay. Now let us take sigma MD that equals to 0. Sigma MD that equals to 0. RC double dash into 5. RC double dash into 5 is rotating clockwise plus minus 10 into load into distance by 2 UDL. This is for UDL. Then next minus 22.15 that equals to 0. Then you calculate RC double dash. RC double dash will get 29.5 kilonewtons. 29.5 kilonewtons you will get. Then use sigma Fi that equals to 0. Then let us calculate RD. Okay, let us take RD as, so sigma Fi equals to, what is that? This will be RD that equals to uh, 10 into 5 minus of 29.5. 29.5. RD equals to 20.5 kilonewtons. So this is RD. Okay, this is RD. This is how we need to calculate the support reactions. Now let us take how to draw SFD for the given this thing. Okay, now what I have to do, let us take how to draw SFD for the given need. So I will show you how to draw your SFD for the given need. Just take copy and you can paste it here. So just I will show you how to calculate, how to show your how to show SFD and BMD. Okay, how to show SFD and BMD. So now let us show SFD and BMD for the respective sections. Let us do SFD BMD. So this thing. So better not to add this. So it's sure here. Yeah. Now you already calculated. So here I got RA equals to calculated 17.15 kilonewtons. Similarly, RB will be RB dash plus RB double dash. So we got this 41.95 kilonewtons. This RC we calculated VC1 VC dash plus VC double dash. So you got 50.40, and this you got 20.5. RD you got 20.5 kilonewtons. Okay. Now let us show SFD BMD for the given B. Okay. Now let us show SFD BMD for the given problem. Let us show SFD BMD for the given problem. Okay. Let us show SFD BMD for. Let us take this with the this is the datum line. Let us consider this is datum line. A datum line means R0 line. You can consider, take it as. So from that datum line, whatever you draw from that datum line, so upward is positive, upward is taken as positive, downward is taken as negative. Okay. Here, what is that? Now start with the 0 here from point A. 17.51, it will come somewhere here. So this is, what is that? Point low, and this is point low. Okay, sorry. Okay, now here it is what? 17.15, 17.15. Here to here is 17.15. Here to here there is no load region. Your SFD varies horizontally. And at this point 40. This is 17.15 kilonewton. At this point 40 kilonewton. So please remember, while drawing SFD, upward is positive, downward is negative when you are coming from left to right. So this is 40 kilonewton is acting downward, means plus 17.15 minus 40, it is 22.85. Let us say it will come somewhere here. 22.85, it will come somewhere here. Okay. Here to here there is no load region. This is 22.85 kilonewton. Then here to here, 22 here. Then 22.8 here, minus 22.8 here, plus 41.95 here. So it is 19.1. So 19.8 will come somewhere here. Okay, 19.1. Then plus 19.1 plus 19.1 minus 10 into 4, it's a 40, so it is 20.9. So 20 means it is comes somewhere 20.9. So it is 20.9 kilonewtons. So now minus 20.9 plus 50.40, 29.5. 29, so it is comes somewhere here. So it is 29.5 kilonewtons plus 29.5 minus 10 into 5, 50. So this is 20 point. This is around 20. It's also 20. 20.5 minus 20.5 plus 20.5, 0, like this. So I started with the 0, I have to end with the zeros. This is plus, this is minus, this is plus, and this is minus, plus, and this is minus. Okay, this is how we need to draw shear force diagram. Now this is how we need to draw shear force. Now let us consider how to draw the BMD. Now let us draw the BMD. So let us draw on dotted line. Okay, here it is subjected to a point load, 40 kilonewtons, unsymmetrical loading is there. So what is the variation? Variation is, first please remember, while drawing SFD, BMD, we need to remember first. Let us draw with due to loading. Due to loading, what is the bending moment diagram? So what is bending moment diagram? So this is due to loading is subjected to a point load. This is like this. That is like this. Okay, this will be what? WAB by L. So WAB by L you will get 48 kilonewton meters. This is due to loading. Okay, now this is UDL. So it is UDL. So this is 20. So UDL, the variation is parabolic variations. The variation is parabolic variations. Similarly, this is a variation is little bit higher variations. So this is parabolic. It should be parabolic. Yes, I'm drawing. Okay. So this is the maximum bending moment. This is also maximum bending moment. This is WL square by 8, 48 kilonewton meter. This will be WL square by 8. You will get WL square by 8. You will get 20 kilonewton meters. 20 kilonewton meter. Similarly, this is WL square by 8. You will get 31.25. So you will get 31.25 kilonewton meter. You will get. So this is the case. Okay. This is due to loading. Now I drawn the bending moment diagram due to the loading. Due to loading we draw. Now let us draw due to the support movements. So you already calculate what are the support movements we have. So at the support movements you already know what is the support movements, 24.34. So you show please 24.34 here. So let us say this is datum 24.34. And at this 18.54, it is lesser than that. Then at this 22 means it is somewhere here. And at this 0. Then let us join those lines. Sorry. Let us join those lines. Okay. So this is minus, this is plus, and this is plus, and this is plus, and this will be minus. You can write the values 24.34 kilonewton meters. This is 18.54 kilonewton meters, and this is 22.9 15 kilonewton meters. This is how we need to draw the BMD, guys. Please, this is how we need to draw the BMD. So clearly, I have shown it here. So what are all the values and everything? So this is kilonewton meters. This is actual diagrams. So how we'll get? So kilonewton meters. This is kilonewton meters. 18.54 kilonewton meters. This is kilonewton meters. Okay, and everything here kilonewtons. Whatever all CFOs are in kilonewtons. Okay, this is movements are in kilonewton meters. Okay, this is BMD and SFD. So this is how we need to represent your BMD, bending moment diagram. This is how we need to represent your BMD bending moment diagram. Okay guys, I hope you understood this example.